Welcome back, Caymans. This is part 2 of a lesson about the quadratic formula in the discriminant. And if you don't have these pages printed out, I'd recommend that you do that. Though we don't have any graphs here, so it might just be fine to copy them down into your notes. So let's look at first number 4. On number 4, you'll do number 3 as a try this. But for number 4, again, the directions are to do 3 things: state the value of the discriminant, the type and number of solutions, and then find the exact solutions. So when using the quadratic formula, you have to make sure that you're in this form: ax squared plus bx plus c equals 0. And you can see on this one that it does not equal 0, so we should add 5 to both sides. So we would get 9x squared minus 6x. Adding 5 to that would be a plus 1 equals 0. And then we can identify what a, b, and c are. You only do that once it's in the correct form, this form, which it wasn't to begin with. So a would be 9, b would be -6, and c would be 1. So the first thing we do is find the value of the discriminant. The value of the discriminant would be b squared minus 4ac. b squared would be -6 squared minus 4 times a times c. We get 36 minus 36, and we get 0, which is a pretty nice answer. So if the discriminant is 0, we would get 1 rational root. That's a real number. We get 1 rational root since the discriminant, b squared minus 4ac, equals 0. On the previous page of the notes, we talked about when the discriminant is 0, you get 1 rational root. And then the third step, we'll find that 1 rational root. So if you're not sure, like, why does that make sense? Why do we get 1 rational root? When we do the quadratic formula, we'd have -b, which makes it a plus 6, plus or minus the square root of the discriminant, which is 0, all over 2 times a. So we get x equals 6 plus or minus 0 over 18. And 6 plus 0 is 6 over 18. And here is our 1 rational root. Our 1 rational root, also known as a double root, is 1/3. That means if you were to sketch a graph of this quadratic function, it's going to bounce off the axis at 1/3. So it's going to come down here, hit the axis, and then go back up. So knowing the discriminant equals 0 tells you a lot about what the graph looks like. It's just going to bounce off the axis at one place, and then using the quadratic formula, we could find where that one place is. That was number 4. Let's look at number 5. Number 5, again, you need to have in the correct form ax squared plus bx plus c equals 0. So we're going to have to move this 4, subtract 4 from both sides. So that gives us x squared plus 4x minus 1 equals 0. So our values of a, b, and c would be 1, 4, and -1. So number 1, the discriminant. The discriminant would be, remember the formula is b squared minus 4ac. b squared would be 4 squared minus 4 times a times c. So we get 16 plus 4. -4 times -1 is plus 4. So the discriminant is 20. And since the discriminant of 20 is greater than 0, but not a perfect square, we have 2 irrational roots. So the number and type of roots would be 2 is the number, and the type is irrational. And then 3, to find those exact roots, we use the quadratic formula. So we have -b plus or minus the square root of 20. That's the discriminant we found right there. All over 2 times 1, 2a, so 2. Now 20 can be simplified. The factors of 20 would be 2 times 10. 10 is 2 times 5. So we're going to take out that pair of 2's. That's going to be 1, 2 on the outside. So the square root of a pair of 2's is a 2. So we have -4 plus or minus 2 root 5. all over 2. And both the 4 and the 2 in the top are divisible by 2. So we could do x equals -2 plus or minus 1 square root 5 over 1. And that's dividing each number by 2. The square root of 5 isn't affected. And we should write this as -2 plus minus square root 5. So those are our 2 irrational solutions. Notice the square root of 5 can't be simplified down to whole numbers, so that's why we get 2 irrational roots. It helps some students just to find this answer, and then you can kind of go backwards and say, okay, now that I have the answer, what type of roots are these? Are they rational or irrational or imaginary? Number 6 is try this. You can do that on your own. And then the last part, we have kind of a summary of what we've talked about in the past several lessons. Summary of methods to solve a quadratic equation in the form ax squared plus bx plus c equals 0. We have graphing. Typically we don't use graphing because it takes a while to graph by hand, but we have 4 main approaches. We have factoring, the square root property, completing the square, and what this lesson was about, the quadratic formula. So what we would like you to do on the next part is state the best method from all but graphing, so ignoring graphing, to solve the following quadratic equations. Then solve the equation using that method. Use one of each of the 4 algebraic types. So I'd like to talk through how to determine what you might be looking for to determine should I factor or do the square root or complete the square or use the quadratic formula. And then as a try this, you'll be able to solve each of these on your own. So something to look for with, we'll start with the square root property. Something to look for is, are there any perfect square trinomials? Perfect square trinomial. So a perfect square trinomial is your constant, like this first one. Your constant should be a perfect square, and we have 2 options. 64 is a perfect square. Now when you do a square root of 64, you get 8. And we want the one that has a middle term that's double 8. So like this first one would have 16, which is double 8. So this first option is a good candidate for the square root property. So you're basically going to factor and write this as a sum or difference of 2 squares and then square root from there. So we've used the square root property. After that, maybe for factoring, you want to make sure it is factorable to begin with. So maybe if we look at this one at the bottom again, are there factors of -64 that will add to -12? And if there are numbers that you can put on the left and on the right here, that would be a really good option for factoring. So for instance, this one over here, you could try to factor and put 7 multiplies to 7 that adds to -4, but there's not going to be any numbers. So you don't want to factor number 8 because it's not factorable for integers. So number 9, you should try factoring. Number 8, since we have a 1 as a leading coefficient, the completing the square is nice when you have a 1 as a leading coefficient. And notice on number 8, you have a 1 as a leading coefficient, so we can kind of set it up to complete the square. We'll do plus blank equals subtract 7 from both sides. So you could figure out what square to put there to complete the square. So we've used factoring, square root property, complete the square. That leaves this number 10 as the quadratic formula. Quadratic formula is helpful when it's not factorable or when you have a leading coefficient that isn't a 1. 7, 8, and 9 all had a 1 as the leading coefficient. Quadratic formula is a good approach when you don't have a 1 as the leading coefficient. Here we have a 2. So as a try this, see if you could solve for x in 7, 8, 9, and 10. Thanks for watching this video. Let me know if you have any questions or let your teacher know if you have any questions. Have a great day.